Morning children. Today in chapter 7 we are going to discuss about integration by partial fraction. Now what are the things we have to learn in this topic? First of all, we will discuss about the meaning of partial fraction. Then the standard formats for expressing a given expression into different terms using partial fraction. Then integral results of some standard functions. And then problems on integration using partial fraction. And after the completion of this unit, you will be able to explain the technique of expressing a rational expression in terms of sum or difference of some terms. Then apply the method of partial fraction to integrate some complicated rational functions and solve different types of problems using integration by partial fraction. And prior to this, you have learnt about the integral results of some standard functions, and you know the different rules like sum rule, difference rule for integration, and also some of the techniques of integration like integration by substitution, means how to solve a problem on integration using the method of substitution. So before we start this, let us first of all recollect some of the basic trigonometric identities which we have learnt it in class 11. Say, whenever a particular trigonometric function is in the form of product, that means either in the square form or cube form, or it is the product of two trigonometric ratios, then how to express them in terms of sum or difference. So some of the basic identities like 2 sine square A is equal to 1 minus cos 2A, 2 cos square A is equal to 1 plus cos 2A. That means here this is in the form of product. We are expressing it in the form of sum or difference. Similarly, 2 sin A cos B, it is sin A plus B plus sin A minus B. Then 2 cos A sin B, it is sin A plus B minus sin A minus B. 2 cos A cos B, it is cos A plus B plus cos A minus B. And 2 sin A sin B, it is cos A minus B minus cos A plus B. And from the formula of sin 3A and cos 3A, we can derive sin 3A is equal to 3 by 4 sin A minus 1 by 4 sin 3A, and cos cube A is equal to 1 by 4 cos 3A plus 3 by 4 cos A. And these are some of the standard results with which you are well acquainted with, like integration of x to the power n dx. It is x to the power n plus 1 by n plus 1 plus some constant. Condition is n has to be different from minus 1. Similarly, integration of cos x dx, that is sin x plus constant. Integral of sin x dx, it is minus cos x plus constant. Integral results of sec square x dx, that is tan x. Integration of cosec square x dx, it is minus cot x. Integration of sec x tan x is equal to sec x. And integration of cosec x cot x, it is minus cosec x. And each of them is followed by some constant, because these are all indefinite integrals. So the result must be followed by a constant. And we know this exponential function is the invariant function. Its differential result and integral results remains the same. Means integration of e to the power x dx, it becomes e to the power x. Similarly, integration of 1 by x dx, that is log x plus constant, and integration of a to the power x dx is equal to a to the power x by log a plus constant. Now coming to this partial fraction, what do you mean by this partial fraction? Let us say that we want to evaluate an expression in the form of integral of px by qx dx, where px by qx is a proper rational fraction. In this case, it is possible to write the integrand as a sum of simpler functions by using partial fraction decomposition, and after this integration becomes easier, means we can easily integrate the resulting function. And these are some of the techniques used for expressing the product in terms of sum or difference. The first kind is some numerator px plus q divided by product of two linear factors. We write some constant a by linear plus another constant b by the second linear factor. If we have say product of three linear factors, then there will be three arbitrary constants, a by x minus a plus b by x minus b plus let us say c by x minus c, if x minus c is a factor over here. Similarly, if we have the repeated factor x minus a whole square in the denominator, x minus a whole square means same factor x minus a is repeated twice. So some numerator divided by x minus a whole square. Then we first write a by linear plus b by quadratic. That means if we have the repeated factor, so out of that repeated factor we write the linear one first, then we write the quadratic. Similarly, product of three linear factors, I have already told you, it is some constant a by x minus a plus b by x minus b plus c by x minus c. And again some numerator divided by product of linear and quadratic, where quadratic is a repeated factor. So we write some constant a by linear plus b by quadratic plus c by linear x minus b. So it is x minus a whole square into x minus b. So now this x minus a whole square, since it is a repeated factor, first we write the linear one, then we write the quadratic, and finally some c by x minus b. And we have the numerator by product of linear and quadratic, where quadratic is not factorizable. In this case, we write some constant a by linear plus bx plus c by quadratic. That means since it is quadratic, which is not factorizable, there must be two arbitrary constants b and c in the numerator. And these five methods are applicable only when the degree of numerator is strictly less than the degree of denominator. And once we find the degree of numerator is greater than or equal to the degree of denominator, then first of all we divide the expression, then finally we have to find out in which format it fits, and accordingly we convert them into sum or difference of some functions. Now using this technique of partial fraction, we will be solving some of the problems. So our first problem is integration dx by x square minus 4, and this x square minus 4 is in the form of a square minus b square. We can write it as a plus b into a minus b. Now since it is the product of two linear factors, we write that 1 by x plus 2 into x minus 2 is equal to some constant a by x plus 2 plus b by x minus 2. Now the LCM of this is x plus 2 into x minus 2, which is cancelled out with this x plus 2 and x minus 2. Ultimately in the numerator, in the right hand side, we will be left with a into x minus 2 plus b into x plus 2. And since it is an identity, so a into x minus 2 plus b into x plus 2 must be equal to the numerator of the left hand side, which is your 1. Now our aim is to find the values of a and b. So we will be using the technique of substitution to find the values of a and b. So by substituting x is equal to minus 2, we will be left with a into minus 4 plus b into 0 becomes 1, and thereby we are getting a is equal to minus 1 by 4. Similarly, putting x is equal to 2, this quantity is vanished. Ultimately, we are left with b into 2 plus 2. That means 4b is equal to 1. b becomes 1 by 4. Now we have found the value of a and value of b. And the same value is to be substituted here. So our integral becomes 1 by x square minus 4 dx is equal to integration of a by x plus 2, that means minus 1 by 4 by x plus 2, plus b by x minus 2. b is your 1 by 4, 1 by 4 by x minus 2. So now term by term integration. So minus 1 by 4 into 1 by x plus 2 plus 1 by 4 into 1 by x minus 2 dx. Now applying the term by term integration, so it is minus 1 by 4 remains as it is a constant. So integration of 1 by x plus 2 becomes log x plus 2. Similarly, integration of 1 by x minus 2 becomes log x minus 2, and it is followed by the constant. So taking 1 by 4 common, it is log m minus log n. So that can be further written as log m by n. Now another question, integration 2x plus 3 by x square minus 9 dx. It is just similar to the previous question, only thing that in the numerator we have got a linear expression. So 2x plus 3 by x square minus 9 dx. Now we factorize x square minus 9, it is x plus 3 into x minus 3. Now it is the product of two linear factors with the condition that degree of numerator is less than degree of denominator. So we apply partial fraction and we assume that 2x plus 3 by x plus 3 into x minus 3 is equal to a by x plus 3 plus b by x minus 3. So now taking LCM, the LCM here becomes x plus 3 into x minus 3, which is cancelled out with x plus 3 into x minus 3 in the numerator. Now in the right hand side, the numerator will be a into x minus 3 plus b into x plus 3, and here in the numerator we will be left with 2x plus 3, because this denominator and this denominator will be cancelled out. So ultimately we are getting a into x minus 3 plus b into x plus 3, that becomes 2x plus 3. Again, by using the technique of substitution, putting x is equal to minus 3, this quantity is vanished. So we will be left with a into minus 3 becomes minus 6 plus b into 0, putting minus 3 here. So it is minus 6 plus 3 becomes minus 3. So a becomes 1 by 2. Similarly, putting x is equal to 3, it becomes a into 0 plus b into 6. It is 6 plus 3 becomes 9. So b becomes 9 by 6, which is equal to 3 by 2. So now we could express this quantity in the form of sum of two quantities. So thereby the integral result of 2x plus 3 by x square minus 9 dx becomes a by x plus 3, a is your 1 by 2, 1 by 2 by x plus 3, plus b is your 3 by 2, so 3 by 2 by x minus 3 dx. Now applying this term by term integration, it is 1 by 2 integration of 1 by x plus 3 dx plus 3 by 2 is taken out, integration of 1 by x minus 3 dx. So it is 1 by 2 into log x plus 3 plus 3 by 2 into log x minus 3, and the result is followed by a constant. Now coming to example 3, we will integrate x square minus 1 by x square minus 16 dx. So here we find that the degree of numerator is 2 and degree of denominator is also 2. Since the degree of numerator is greater than equal to denominator, we divide. So here degree of numerator is equal to degree of denominator. So first of all we divide x square minus 1 by x square minus 16, which becomes 1 plus 15 by x square minus 16. So now this x square minus 16, we can factorize it as x plus 4 into x minus 4. So it is the product of two linear factors. We write 15 by x plus 4 into x minus 4 as a by x plus 4 plus b by x minus 4. So now we can write a into x minus 4 plus b into x plus 4. That becomes 15, because here the denominator LCM becomes x plus 4 into x minus 4, which is cancelled out with the denominator x plus 4 into x minus 4 in the left hand side. So ultimately we will be getting a into x minus 4 plus b into x plus 4 is the same as 15. Now again, by using substitution, putting x is equal to minus 4, we are getting a into minus 4 becomes minus 8 plus b into 0, that becomes 15. So a is 15 by 8. A is equal to 15 by 8 with minus sign. So a is equal to minus 15 by 8. Similarly, putting x is equal to 4, this quantity is vanished. So it is b into 4 plus 4. That means 8b is equal to 15. b becomes 15 by 8. Now putting the values of a and b in the given integral, we will be having integration of 1 plus a by a means minus 15 by 8 by x plus 4 plus b is 15 by 8 divided by x minus 4. So it is 1 minus 15 by 8 into 1 by x plus 4 plus 15 by 8 into 1 by x minus 4 dx. So applying term by term integration, integral of 1 dx becomes x, minus 15 by 8 is taken out, integral of 1 by x plus 4 dx becomes log x plus 4. Here I mean log means base is e, natural logarithm, plus 15 by 8 is taken out, integral of 1 by x minus 4 is log x minus 4 plus constant. So it is, on further simplification, it is x plus 15 by 8 into log x minus a, x minus a means x minus 4 minus log x plus 4 plus constant. Because again it is an indefinite integral, the result must be followed by a constant. Once the integration gets over, we put the constant quantity c. Then one more question. Integral of x to the power 4 plus x cube plus x square plus 1 divided by x square plus x minus 2 dx. Here again we find that the degree of numerator is greater than degree of denominator, because the degree of numerator is 4 and the degree of denominator is 2. If the degree of numerator is greater than or equal to degree of denominator, so we have to divide. So first of all we divide x fourth plus x cube plus x square plus 1 by x square plus x minus 2. So on division it becomes x square plus 3 plus minus 3x plus 7 by x square plus x minus 2 dx. It's just simple division, so we will be getting this. Now this is equal to integral of x square plus 3 plus minus 3x plus 7 divided by factorizing this x square plus x minus 2 using middle term factorization. We will be getting x plus 2 into x minus 1. So it is the product of two linear factors. So we write a by x plus 2 plus b by x minus 1, because it is the product of two linear factors, and this x square plus 3 remains as it is. So now the numerator of the right hand side becomes a into x minus 1 plus b into x plus 2, and the LCM becomes x plus 2 into x minus 1, which is cancelled out with this x plus 2 into x minus 1. So the numerator of the right hand side now becomes the same as the numerator of the left hand side. That means a into x minus 1 plus b into x plus 2 becomes minus 3x plus 7. Now applying substitution, taking x is equal to minus 2, we will be left with a into minus 3 plus b into 0 is equal to minus 9 plus 7. So a is minus 3, minus of minus 3 is plus 9 plus 7, it is minus 2. So minus 2 into minus 3 is plus 6 plus 7 becomes plus 13. So a into minus 3 plus b into 0 becomes 13. So a becomes minus 13 by 3. Similarly, putting x is equal to 1, this quantity is vanished. So b into 1 plus 2, 3. So that means 3b. It is minus 3 into 1 is minus 3 plus 7, that becomes 4. So b is 4 by 3. Now we substitute the value of a and b in this expression. So our integral becomes x fourth plus x cube plus x square plus 1 divided by x square plus x minus 2 dx becomes x square plus 3, plus in place of this quantity we write minus 13 by 3 by x plus 2 plus 4 by 3 by x minus 1 dx. So using term by term integration, integral of x square becomes x cube by 3. Integration of 3 becomes 3x. Minus 13 by 3 is taken out. Integral of 1 by x plus 2 dx is log x plus 2. Plus 4 by 3 is taken out. Integration of 1 by x minus 1 becomes log x minus 1, and it is followed by a constant. And one more question, in which we will be having the product of three linear vectors. So we have x square plus x minus 1 by x into x square minus 1 dx. So here the degree of denominator is 3, but the degree of numerator is 2. So the degree of denominator is greater than degree of numerator. So directly we apply the technique of partial fraction. So integral of x square plus x minus 1 divided by x into x square minus 1 dx. That becomes integral of numerator remains as it is. On factorizing the denominator, it becomes x into x plus 1 into x minus 1. Now since it is the product of three linear vectors, we write it as a by x plus b by x plus 1 plus c by x minus 1. So this is, on taking the LCM, the denominator becomes x into x plus 1 into x minus 1. This is cancelled with this denominator. In the numerator on the right hand side, we will be left with a into x plus 1 into x minus 1 plus bx into x minus 1 plus cx into x plus 1. That becomes the numerator of left hand side. It is x square plus x minus 1. Now we have three arbitrary constants a, b, c. Taking x is equal to 0, we will be left with a into minus 1 plus b into 0 plus c into 0 is equal to 0 plus 0 minus 1 is minus 1. So a becomes 1. Similarly, taking x is equal to minus 1, we will be left with a into 0 plus b into 2 plus c into 0. Again it is minus 1. So b becomes minus 1 by 2. And finally, taking x is equal to 1, it will be a into 0 plus b into 0 plus c into 2 is equal to 1 plus 1 minus 1 is 1. So c becomes 1 by 2. So by taking three different values of x, we have found a, b and c. So we found a, b and c. So now the given integral becomes a by x, a is 1 by x plus b by x plus 1 means minus 1 by 2 by x plus 1 plus c is 1 by 2 by x minus 1 dx. Now applying term by term integration, integration of 1 by x is log x, minus 1 by 2 is taken out, integration of 1 by x plus 1 is log x plus 1, plus 1 by 2 is taken out, integral of 1 by x minus 1 is log x minus 1 plus constant. So it is log x plus 1 by 2 taken common, log x minus 1 minus log x plus 1 plus constant. Now some of the questions are given for homework, so please try to solve these questions. Thank you children.